Okay, Honor Chem Kids, we are going to talk about how to um, how to do Lewis structures and how to also um, draw resonance structures. So, in order to do Lewis structures, we learned about single bonds. There's also double bonds and triple bonds, which we call multiple bonds, that I'm going to show you in this video how to do. If we had something like carbon dioxide, the first thing we would want to do is to sum up the valence electrons for carbon dioxide. So carbon has 4 valence electrons, oxygen is 6, and we've got 2 of them. So that would be a total of 12, which gives me a total of 16 electrons for carbon dioxide. Drawing the structure is still the same, similar to what we did with single bonds. The central atom is going to be carbon because it has the most places to bond into, and I'm going to draw 2 oxygens on either side of that carbon. When I do that, I have used up 4 electrons in those 2 single bonds, so I now have only 12 electrons left over in order to get this molecule to have an octet. Every element has to have an octet. So now what I do is I'm going to complete these in pairs. So I'm adding pairs of lone electrons, and I'm going to add them first around the oxygen atoms. So the first one here is going to be oxygen. So there's 2, and then there's 4, 6, 8, 10, and 12 oxygens, and that's it. I no longer have any oxygen or electrons that I can add up. I can't conjure up any oxygens at all. The problem becomes is if you look at the oxygen, oxygen's in control of 8 electrons. This oxygen on the right-hand side is in control of 8 electrons. But the problem is that carbon is only in control of 4. So what can happen is we can make a multiple bond. And what happens in the multiple bond is that this set of electrons right here can move in between that carbon-oxygen bond. So it's going to look something like this now. So we're going to have oxygen with 2 bonds, and we draw a double bond on this carbon, and this oxygen is still going to look like this. So now the oxygen on the left-hand side is in control of 8 electrons. The carbon is getting closer. Each dash represents 2 electrons, so that's in charge of 6 electrons. So the other side of the electron right here, that also can fill in and make a multiple bond. So overall, the molecule ends up looking like oxygen, double bonded carbon, double bonded oxygen, with 2 sets of lone pair electrons on each side. Okay, that is how we can arrange a molecule with multiple bonds and still have an octet. All right, on the next slide, what I want you guys to do is I want you to actually recognize that a double bond is 2 pairs of shared electrons. And in this case, you would have 2 dashes, represents a double bond. And in some cases, you can have a triple bond, which would have 3 dashes. There would never be a quadruple bond. It does not happen with the electronic structure. So your only options are single bonds, double bonds, or triple bonds. What I'd like for you guys to do now is to try on your own writing out the electron cache for these molecules that I've written here, okay? I'd like for you to pause the video. I'd like for you to then write the electron cache and then draw the structure. Okay, hit pause now, do that, and then when you're ready, come on back. Okay, so the structure for N2 should look like this. You should have had 10 electrons in your cache, and N2 should be triple bonded. Oxygen you should have 12 electrons in your cache, and oxygen is double bonded. And cyanide ion, when you count this cache, remember carbon has 4, nitrogen has 5. Oh, and you add that together and you got 9, and you might be saying, uh-oh. But remember what this negative means? This negative here means that you're adding 1 extra electron. So you have a total of 10 electrons. So this structure is actually triple bonded, and you have to remember to put it in a bracket and show that overall negative charge as well. Okay? And that's how we write and show double bonds and triple bonds, which are called multiple bonds within the Lewis structure. The other thing to recognize here is that a triple bond has a larger bond energy and a shorter length than a single bond. So here's a chart that you'll notice there's a carbon-carbon single bond here. And when you look at that carbon-carbon single bond, it has an average bond length of, so let's see, I can probably take a look at it here, is that this has an average bond length. I'm trying to get a pen going here and not being successful. So we'll just have to have you take a look at that carbon-carbon bond. Has an average bond length of 154. If you have a carbon-carbon double bond, the bond length is 134. Do you notice that that shrinks up a little bit, which is intuitive? The more multiple bonds you have, the bond length gets shorter. Also, look at the average bond energy. The bond energy of a carbon-carbon bond is 346 kilojoules per mole, and the double bond is higher than that, 612. And a triple bond is even higher than that. So as you increase, and here's what I've got here, is the triple bonds are stronger and shorter than double bonds. Double bonds are stronger and shorter than single bonds. Okay. So what I'd like for you to keep on trying is I would like for you now to draw the Lewis structure for the nitrate ion, NO3. So I want the electron cache, and I would like for you to draw that structure. Hit pause and return once you've had that structure written and you want to see what it would look like. So hit pause now. Okay, so the structure or the amount of cache for nitrogen, nitrogen has 5 valence electron, oxygen has 6, and we've got 3 of them, so you have 18. When you add that together, you get 23 electrons. But this negative here means that you are adding 1 more electron, so you have 24 electrons. Now to draw this structure, I'm going to put my oxygens, and when I do that, I've used 6. So that means I only have 18 electrons left to get this stable. So I'm going to go 2, 4, 6, 8, 10, 12, 14, 16. And then I'm going to put the last 2 right here, 18. Now you'll notice oxygens, all of the oxygens have their octet, but nitrogen does not. So what I'm going to do is I'm going to take this pair of electrons and I can move that in to make a double bond. And it doesn't matter where you put that double bond, just as long as there is 1 double bond in this structure and 2 single bonds. Remember, since it's a polyatomic, we have to put it in brackets and we've got to show that negative charge. Okay? When more than 1 Lewis structure can be drawn for the molecule, we call that a resonance structure. And resonance structures actually are considered to be, the electrons are what we say localized around that whole structure. So what that means is that that double bond could be really anywhere within that whole structure. To write that, we would then show the 3 resonance structures for that nitrate ion. And here would be the first one, with the double bond being on this side. And you'd have your bracket with the thing. Then you show a double arrow to mean that these are equivalent. You could also have the double bond on the right-hand side. So here, 2, 4, 6, there's 2 here. There would be 2 here. I don't know if you can see. Let's see if I put this down here. I'll put this other one here. Let's just put that. There you go. And finally, the double bond oxygen can be on the bottom type. Oops, I messed up there, so let's erase. This is only going to have 2 pairs of electrons. This oxygen would have, and you can see we're going to put this in a bracket as well. And that's called resonance structure. I will not ask you to write the resonance structures all the time, but if I specifically ask for all of the resonance structures of that one molecule, you would have to write all possible resonance structures, okay? So that is what we, that is how you learn how to, or hopefully, did you figure out and learn how to draw Lewis structures with multiple bonds? And did you learn how to draw resonance? Hope that helps. Good luck.